Okay, are you ready? In our shotgun teaching method, one topic after the next one, it's just thrown at you. Okay, for me, it's at least the last topic. Let's see if Marcus makes it to the physics at the end. So we will do a little bit of lasers, and what I have here is a laser from a Berlin company called Laser Animation Sollinger. They are in Schöneberg, really nice bunch of people. They make really good lasers. It's also the lasers that we had on Deep Web. We had bigger lasers, but it's the same brand. Very precise. They also have a lot of safety stuff going on inside the laser. They accept very high sample rates, so they can be really precise in their movements and very clear and accurate. So yeah, this is this is their smallest laser, and I'm interfacing with the laser with this small little piece of hardware. I will tell a little bit more about it later when we use the relevant shop for that. So in general, what you always have to kind of remember if you do shapes or stuff with the laser is that actually, like most of the lasers that we use, they only shoot one beam. And if we see like a circle on the wall, it's basically just because our eye is too slow to see that it's one beam circling really fast. And it kind of generates this circle image in our brain. And this kind of so-called steering of the laser beam is done with two mirrors. Really physically kind of deflecting and steering the laser beam to the position that we want it to go. So this is something that you have to keep in mind if you, for example, if you want to draw like a really hard rectangle, it actually does, of course, obey the laws of physics, and two motors where the mirrors are attached on, they cannot just kind of break and go from 1 second to the other into like a completely different direction. We will look into that now as well, like how can we handle these things. But in general, that's something that you have to kind of always keep in mind, that you basically have a physical steering machine with two motors that actually deflect one laser beam. It also has its limitations. But limits are always good for finding clever solutions. This whole process of kind of moving the beam is called scanning. This is also like our center chop that we use, and what Touch Designer offers for handling lasers is the scan chop. And as I heard from Marcus, this chop was kind of produced to drive an oscilloscope. These where you can see like data or electricity stuff, and they kind of work in the same way. So that's kind of where the scan chop comes from. As we can see, the scan chop has this source menu. So basically we can use tops, subs or chops to create shapes. For today, we kind of concentrate for the, in my opinion, most important one is to work with subs. It's kind of the, I guess, area in which a lot of people in touch are not so much familiar with. So it's kind of maybe also interesting to just have a little bit of a deeper dive into the sub area. Yeah, and let's start with a very simple sub, and let's draw a circle. Okay. I already want to make this a bit smaller. Dot 1. Now this circle has 40 divisions, and let's just go ahead and put the null, and let's throw it onto our scan job. First we need to change our source to sub, and then in the sub page we can drag our null 1, and there we have this behavior.
Basically audio that you listen to too.
Yeah, it's like an oscilloscope. It's an oscillation. We can actually let's listen to our circle. Yeah, we did that yesterday. Okay, so basically, if we put the middle mouse on top of that, we see that the scan job is 1 frame long, and you can also see it here in the values. Dot 0 basically, dot 2, dot 4, dot 6, dot 8, next number. So this is 1 frame long, and it has 800 samples. And this 800 results from our sample rate here in the scan job. Because 800 times our frame rate 60 is 48,000. So basically, this scan job has 48,000 samples per second. And this is kind of the values that we send at the end to the laser. We actually don't send 48, but we can also change it to 96,000. And we also see here our 1 frame long job has now 1,600 values. And so basically, the scan job takes the input, which is a circle with 40 points, and it just scans this these numbers. And if we change this, for example, let's change the divisions to what did we have? 400. We actually see now that we have kind of 4 circles in that second. And let's make it a little bit even more obvious. Let's make 1,600 divisions. And then we have basically one X and Y. So basically, if we would send that to the laser, he would in one second draw. No, actually, in 1 frame, he would draw 1,600 points, or it would steer to 1,600 points to draw the circle. So actually, the laser gets 96,000 points per second from us that he kind of tries to shoot at with 1 beam. Let's go back and go to 400 divisions. Stefan, hast du den Laser? Musst du hinten den Powercon nur so reindrehen? Ja. Gibt da, oder hinten müsste es jetzt so. Okay. You don't have to do that, but I will for now, I will scale down my X and Y values. So I don't have like a huge projection here. I will also multiply this by dot one and dot one. And I also don't have to make my first circle so small. Okay. Scan job, let's have another look. Let's add or enable output color. So now we also see RGB, RGB, RGB in our scan. And what you see here, this basically after each circle, you have this one little pulse or like a bump that goes down to 0. And this is our blanking point. When you turn that off, it's basically a line, but let's keep it at 1. Blanking is kind of a very, also a laser specific term. It's when you have shapes, like let's say you want to draw 3 circles. The blanking, you basically just have information of 3 rings. And the blanking is kind of, it turns off the laser while it goes from one shape to the other shape. And this is kind of the blanking count, is how many of these dots do you want to turn off between the laser beam traveling from one circle to the other circle. You will understand it a little bit more when we go further. So I will just quickly check if I'm connected with the laser. It seems so. Okay. Very nerdy laser animation toolbox. Okay. Yeah, maybe a few words to that. I'm actually not a super expert in this LA toolbox, but basically it's also from Laser Animation Soldinger. They use that to kind of, you can calibrate how strong is the red, the blue, or the green, network settings, IP address of this thing because we are sending it over network. I will say a little bit more about AVB in a second, but here we already have the sample rate on which the laser is working, 96,000 Hertz. Some safety regulations, and I will go quickly into this projection. I will turn it down a lot first. Okay. Okay, so I will do it here in their tool, but it's actually also something that you can do within Touch Designer. But basically, what this tool enables us is to kind of, it's like a Kantan mapper for lasers, or like a Camch mapper for lasers. Basically, we can declare our square, which is in laser terms from -1 to 1. So if we tell the laser to shoot to -1, it goes the furthest it can here, and 1 to the right, and the same in the y direction. It doesn't go from 0 to 1 or not from minus 0.5 to 0.5, a laser gets the values minus 1 to 1. And basically with this square, I'm telling the laser what is my minus 1 to 1. So for now, I'm just gonna stick it into this corner. Does it look straight? Okay. So now nothing will shoot somewhere here. Okay. ADB. Okay. So now let's output to the laser. And now I also come to ABB. Sorry, this is all a little bit of name dropping and stuff like that the whole time, but let's get these things straight away. So this thing, what I'm using here is called, it's from RME, it's called Digiphase AVB. And a little bit like Markus already said, it's like an audio wave. And basically, in touch, what we will do is we will use a audio device out. So we will actually talk to the laser as if it would be a speaker. And basically, we will send these values, X, Y, and RGB, and we will send it with the audio device out. And you probably won't have this in on your computer, but I'm sending this circle now to the laser. So let's make it big. Actually, this one can be on 1 now.
There's still the blanking thing.
Yeah, we have blanking on 1, so we are on 0 now. And what I remember, I had I'm on 25% now.
How many watts do you think later?
Oh shit, I didn't look it up. I had this question already this morning. I will check and then I will say. I don't know it exactly. Yeah, let's brighten down a little bit. Let's add a SOP after our circle. Let's put a point SOP.
So question, how much is the laser like that?
This one is approx 8K. Not among the. Yeah. Okay, so now we have the point SOP, and what I want to do now is I actually want to give this this circle a color. So we don't keep the color, we add color. And what this is doing by default, it's kind of just it's taking me input color dot 0, which means the R value, dot 1 is the green value, and dot 2 is the blue value. So it kind of just keeps the color. If we replace red by just saying I want red, maybe here. That's funny. Ah, there you go. And we used a few operators and we're actually also already there. That's kind of the general process here, at least on this setup. So we have a circle with an amount of points. We can add color at some point. We have our scan chop in between. You have to adjust the sample rate according to your laser or according to your interface. I have a Ether-Dream here as well, which is kind of the starter kit. It's also a very nice tool to use, but there you can kind of only have a sample rate of 24,000, which is a fourth, and it kind of gives you quite some, or at least a few limitations if you don't have as many points that you can shoot at. And also just for reference, there is the Ether-Dream chop, and this is also really I also really like it. It's as simple as that. If you have an Ether-Dream connected and you have the IP settings, you are up and running. So this is kind of really nice. The workflow is really as simple as we see it here. Okay. We could, it's, you don't really see anything on your laptops. We could make a fast preview with some instancing what we did before. Looking at the time, maybe we can just skip that. It's all in the files that you have. But maybe I just want to show you a few things that help you get going. There is that.
What happens if you reduce the number of points to 4? Will it start to blink, or will it be?
Basically, it's not enough points for the laser. It will kind of make the circle too small.
Yeah.
So it kind of, this thing is just rotating, and because of physics, because it already wants to go to the next point, it stays in a really small circle. It just cannot handle all the points.
Is that a problem with the scan shop?
It's a physical, well,
I'm just wondering because the scan shop has an option for on the scan some page. You can limit the step size, or
I think that's I don't know.
like if you would repeat the vertices by 40, for example, the parameter,
Yeah.
I just wonder if you then could draw or by even more, if you repeat it by 50 and make the circle only have
you will probably repeat on the point.
Yeah.
Vertex repeat. Yeah, but why not? Okay. But that was actually what was before one, right? It's actually a good point because the there's another word next to blanking. Here, another typical word is the so-called repeater. And that is necessary if you draw rectangles, is you in the where you have the corners, you don't want to just place one point at that corner, because the laser kind of treats every point in the same style, so it will just really run through it super quick and it will make round edges. So everywhere where you have an edge, you have to add repeaters. So basically you say to the laser, hit this point 10 times, and then you have really nice edges. So what we could do is, let's take the circle and let's make a triangle. And if you have the viewer open, right click the display options, and I'm just displaying the number just to show you the difference between closed and open arc. Here we have 3 points. It's 0, 1, 2. But actually what I want is also to kind of, if I draw the triangle, I want to close it back to the first point. So if it's an open arc, you kind of don't see it, but there's number 3 hidden behind 0. And let's go and check the files that you got from us this morning. And I added this Tox here, path creator. There we go. And I just gonna plug my circle into it. And I don't want to write this script sub with you, but let's just quickly go through it together. Okay. Okay, that's the limit. Basically what I'm doing here is I'm optimizing shapes for the laser. And yeah, Marcus, you're right, this is something you can also do in the scan shop. And I don't know, lately there was also a project done with Touch where they actually wrote their own C++ scan shop. Marcus is actually also meeting Laser Animation Zollinger on Monday to have a little bit of a talk. So this is something can be quite interesting what's going to happen. So basically I'm adding these float values, divisions, repeaters, and blanks, which you can see are in my custom parameters. And depending on these values, I'm kind of rewriting or rebuilding the triangle or whatever shape I put into it. And if we add, do you all have this Tox in your network?
Creator.
Yeah. It is in the workshop 202 folder that you got this morning, and in 04_laser you have the path creator Tox, and you just drag and drop it onto the network. And if you have it in here and we put our open arc circle with 3 divisions, which makes up a nice triangle, into here, we end up with a new shape. And I will add a point sub afterwards. Yeah, if you want, you can do it. I'm just kind of, what I'm doing is multiplying the Z value with the index of the input point. Or maybe 0, 1. Or maybe even 0, 5. Okay. So basically this kind of displays what happens. So I'm kind of going along this triangle, and at the beginning I'm setting some blank points, which I will then later on tell the system to not give it a color. And then always in the corners, this is my count for the repeater. If I go back in here, if I cancel away my repeaters, I just basically go along the triangle with the number of divisions in between. So if I only have 3 in between, this is my points. You see they're not growing very fast. So let's keep it at 50. I do add some repeaters, and I will add some blanks at the start and at the end. Okay, so now we have a nice set of points. And let's make a sub to chop. And let's make another one. And I added a special attribute, the blanking attribute. I mean, this is all something that somehow happens within the scan chop, but I think, or at least for me, I could get like, it's more adjustable for me if I can have it in my own subs.
How does it recognize the edges? Would you round, if you would round the edges of the circle, would there still be this repeated, you still have the repeated dots?
In this case, I'm kind of iterating through the points.
Okay.
It doesn't have like a angle recognition thing. This is something that would be definitely something rather in a scan job. Okay. And in a way that we added color here with the point sub, I want to add another way of adding color to a sub. So let's just make a noise chop. And in the channel, the end I switch to samples and I reference to our null sub. and I will call them RGB.
-1.
Oh yeah, -1 of course. So 3 channels RGB, all with amounts of samples as we have points. And as I said, let's multiply this with our blanking attribute. So we put them both into a math job and we multiply. And let's merge them together. For one, we had this already with the pixels, TX, TY, TZ, and RGB. Let's place a null. And after that, let's use the limit sub. There we go. And now we have to tell the limit sub to use TX, TY, and TZ. And for red, green, and blue, we have the RGB that we can tell it. Okay, actually I want to rotate my circle to be looking upwards. 30, no, -30. Yeah. Okay, so what happened now? Ah. Definitely we can scale this. Stefan, du bist in Sicherheit? Okay, I don't like this noise. And yet again, I will make use of the seconds to translate it. Okay. And now one nice cheap trick that you can do is the copy sub. So after our limit, let's make a copy sub. And make 10 of these and scale them down.
Without the blanking, you would see connections between them, right?
Yeah, I can now kind of play around here with these values. If I put out the repeater, I get this shape. Because what the scan job does is it basically knows that here is a point, but it cannot go like that. It kind of, it has to, yeah, what's it called? Zentrifugal Kraft. So yeah, repeaters are very necessary. And the blanks, now actually my noise is not very handy.
No feelings.
Always random. So you can see this weird line. My mouse, of course, doesn't reach it. Would be cool to go over into a laser mouse.
Right.
Yeah. So when I go back with my blanks, it disappears. And the good thing is, you can use this. Now it's of course 30 with all kinds of shapes. Okay. There was one thing. Now the color green is actually nice. Let's translate. We have a Christmas tree. It's now getting out of our 0, -1 to 1. So let's translate the whole thing back. Merry Christmas. Ah. Okay.
Will you emulate the shape now? Or just follow trouble?
I mean, we could, like if we say rotate, let's put that on a, this can actually be faster. Okay.
Can you explain again the path creator? I mean, I roughly understand what it does, but why you need it? I mean, is it to optimize the geometry, right?
Exactly,
More points in the corners.
More points in the corners, and to add this this blanking at the end.
And that gives you better performance.
It gives you clearer shapes. Exactly. Yeah.
What if you just put the triangle straight into the
A triangle with 3 points will end up in a 0 image. It's just 3 points so many times that actually the laser wouldn't move.
Okay, and I see. Okay. I mean, there should be a way to create more points on the.
I mean, there's also, of course, the chop way of doing that. Yeah.
About very nice. Yeah.
I mean, that's how I started to do it as well. Is basically having this shape, then you make a chop, then you stretch it so you have more points, and you always add the last point, like you stretch that as well, you add it at the end, but now basically I put everything into one script cell.
I see. That's true.
And there is an easy way to speed scan.
Sorry?
Like when you press scan speed, because this one is employed.
Scan speed here.
Yeah, there is an easy way
What easy way? What you say?
to press scan speed, like just from the laser, just in points. Just from the shape.
You mean in this copy the rotation? No,
No, instead of
the scan chop.
yeah. No, usually the laser you have this scan speed that you can just from just a line, you just point the line.
Uh-huh.
Is a way yes, yeah.
Not that I know of,
That's website.
but the scan speed is kind of the sample rate.
Yeah.
Like with the sample rate, we tell the laser how many points he should hit per second.
Yeah.
That's kind of the scan speed. And I mean, of course it could be too fast if you wanted to go slower, but if you have only 24,000 points per second, you can only draw, let's say, 4 triangles, but with 96 you can draw 16. So you just have much more points to draw things with.
There was a pixel laser design studio that made like so you can't see it with the eyes, but if you use the camera and look at the laser, it kind of like draw shapes in the air.
Okay.
With pulses, is there a way to do that? Like, I think it matches the frame rate and like figures out how many pulses to do. How to do that like this?
I don't know. Like I don't know. I haven't used this laser, but like you say, it kind of matches a frame rate from a film camera, and then
Yeah, like I think it matches the frame rate and then it pulses it out, and then so you can hack it like ribbons of lasers in the air. You put it in your camera.
Somehow they film synchronized with the pulses of the laser, and you get like crazy storms in space which look like the light which is on that video.
Yeah.
Audience can see it.
Yeah.
The ones that I saw
Okay.
was
Yeah, because they sync it in a way that basically see the laser on its way.
That's not possible. Light is just there. Okay. Well, I guess I just basically want to show you a few tools that you can use, and the copy tool is quite handy. And one thing in the copy sub which kind of comes very handy is the so-called stamping, and that's what we want to do now. So let's just grab this whole bunch here up to our copy, just before our copy, including the limit, and say copy paste. And let's do that with a rectangle. And actually we can get rid of, or no, we don't get rid of this, but we rotate it by 45 degrees. So now I have this. And let's go again and add a copy sub after the limit, And this time we won't use the number of copies within this parameters, but we actually feed a value, another SOP, which we kind of did also in the LEDs. We will add a grid. Oops. Uh, 2 by 2 grids. Smaller. Okay. So what stamping does? Stamping basically enables us to do things with this input data SOP. We can kind of do something with each of these inputs. So now we have it basically times 4. And what we do here with the copy SOP, if we say, no, actually we cannot do anything here. I want to basically scale each of these inputs individually within this copy SOP. And that's what we can do with stamping. So let's just turn stamping on. And we also go back to good old T-script. And okay, so let's give 2 variables, PT and NPT. And here we have to put an expression into the value. It's $PT. Okay. And basically this is the T-script way of saying input point, the index, and it counts from 0 to 3 because we have 1, 2, 3, 4 inputs. NPT is the overall number of points. So if we go and say $NPT, we have 4. Excuse me? 0.5, and it's 2 by 2 rows and columns. Okay. Now, it was kind of difficult for me to understand that, but this variable, we can now use it upstream in the SOP. So let's go and put the transform before. And let's now generate 4 values, which we will use for scaling our rectangles. So let's just go and create a, what should we do? A beat. Let's make 4 of them. Let's cut to the chase. Let's not use references. Let's make it much slower. Period 32. Okay. I'm gonna shuffle this. Sequence all channels. And put a knob. And now let's go and use these values within the transform. And I want to scale my rectangle. So that I want to scale x and y. Yeah. So I need to do that quickly. Okay. So first of all, we reference our null 6. And we reference sine 1. And now basically we want each of these copies to pull another. Maybe I need to put a shift in between. There we go. So this is our, I just put a shift and used absolute to kind of shift the index of the sample back to 0. So now we have 4 values, and in this transform, so now actually they all are scaled in the same way, so I kind of need to tell them what index we are using. And it's another, let's zoom in. And now it's this function fetch stamp. And we are fetching the stamp PT. Oh, no. I think we have to. Yeah. Yeah.
And the default value.
Yeah. And let's use that for y. And now we see that each of these, now we actually, oops, let's go back to the percent of the, probably wasn't the best to use this this beat shift offset. Is there a nicer way? Now they always double because it's a sign. Okay, sorry. Rename. Sign 1. Yeah. Now let's get rid of randomness. And let's use something in here, and that is a null. Let's get all the position of my squares. So let's go and add a null afterwards and go to a subtle chop. So this is all my points. And let's put a math after that. Basically what I want to do is I want to have these points look up the color value from a 2D texture. So now, like we did in the LED part, let's put a ramp, a radial ramp with steps. Oops. And this one we also need to apply or ranging again. Top 2. It's all a bit quick, right? So we can again combine tx and ty with the merge. And now limit tx, ty, tz, rgb. Is always good. So now we shifted this whole thing to the top right because we are actually using this math, which we just need for the color picking. So let's just go. So now we see that we actually haven't got the blanking on anymore because we don't use this attribute, but we do have it in the scan job. Okay, let's do it the right way. I need to add it now. Basically, here I need to add it into the merge. Need to custom attributes B. That's stupid. B1 it's called now. Sub2, I just gonna go quickly through it, guys. There we go. And we need more blanks. Okay. Anyone knew what happened? I guess, oh, okay, 26. Yeah, it's kind of difficult, but what happens here is, in this copy sub, each of the copies gets a different scalar from this sine wave, or from this ramp actually, and we have to put this kind of beforehand. This is a very important tool to use, the stamping, You can also change the location of each of the copies. You can change the rotations. If you do something like deep web, for example, basically you have 175 points and you copy stamp them to the location of where they kind of were hanging in space. And this is the copy, so this is a kind of a very interesting pair, the transform and the copy.
So you basically just work with single points and all the laser will just always go to the same point. That's how you get that.
Yeah. Right. Basically, also in Deep Web, we didn't shoot a point, but it was like a tiny circle. Yeah.
That's what I was saying before. The points you were blanking different.
Yeah. Yeah, because a single point is
So that's what I was thinking before. Usually with laser, if you make a line, you just have one spot.
Yeah.
That's what I mean by scan speed.
Ah, that you mean with the scan speed, like how fast you.
You will do like this and just point.
Yeah. Okay, now I get the question. Yeah. No. Yeah. Well, basically, that's what you would have to animate the scan speed yourself. If you want to have it like quick, like I mean, at the end, it was this kind of stuff was then done with Ableton, and then we took like the speeds from Ableton to define how quick the scan is going, stuff like that.
And is there a way to avoid the T-script nastiness, or is this?
I mean, it's just these two variables, so I kind of.
There are you go to the Python help of it. I do understand that the T-script is much shorter than if you go to the Python help of the copy sub.
But I'm not. Am I online?
Oh.
No.
I'll just turn off the hotspot.
Yeah, maybe that's, yeah. So that would like these two points.
But let's hang on to T-script, at least in one operator. Get this a bit.
Now I don't know why, but it was flowing. I mean, this thing is working, but it dropped down to 0. Yes. It's working. This thing that was wrong.
Yeah.
Yeah, but it's dropping down to
0. How many copies do you make? Like your grid input.
2.
So is the you probably are not able to check the cook time, right, on the copy?
No.
It's a little point. There's something here. Right here we have 59,000 points.
Yeah, yes.
But is okay? Where could that have happened? Do you all have after the path creator in the null? I have 325 points. How many points is in your limit? Should be the same amount actually.
It's the noise.
Huh?
It's the noise.
The noise.
The noise length.
The noise length. It stretches, yeah.
The noise channel is one. On the channel gauge, when you set the length, you gotta switch it from seconds to centimeters.
Oh, yeah.
Make sure thing vividly now creates 300
Yeah.
seconds and 60 lines of download. So,
This is the expression that you need to use. Now the flickering starts. Too many points.
so how many points can you draw?
Well, basically, I have like approximately 1,600 points per frame.
Yeah.
And now I have 1,950 points, which is apparently still okay. But basically what happens is, if you have too many points, it doesn't make the whole shape in one frame and continues the shape in the next frame. And it basically, there is never one still frame.
Right.
And that's why it starts flickering. It's basically because you actually never see, this actually looks a bit weird as a flicker. I'm meaning a different flicker. I think the problem is coming from somewhere else. Now this is the flicker which I mean.
Oh, okay. But it's still pretty much drawing the.
Can you please show me what you put in the map?
In the last what?
The map tree.
This one? And math 4 here?
Oh, there's another map.
So after I pick the position, I have to arrange the position. So we can use the positions here in this top two, so it's basically from -.5 to .5. And this math here is combining these two input chops. It's for one, the RGB values, and they are multiplied by the blanking attribute. So this is a combined chops and a multiply. Let's see how. A section?
If you would send him single points which are not connected, it will still draw a line.
Yeah.
Because it moves from
yeah.
less to the banking.
Yeah.
Can you show again where the blanking?
Where the blanking? So basically, yeah, it's a kind of a, as you can see, like a unusual workflow we have here. But so the blanking is what we have from this path creator. We could have skipped this step, but this was still with our random thing. So we have a limit sub here with tx, ty, and tz, RGB, and also our custom attribute b for blanking. and we have to give it the channel B1, which we get from here. Yeah, it's a bit unfortunate with the naming because the blanking gets B1 because of the RGB. And we kind of have to pull this blanking through, and also after the copy SOP, we have to have a SOP to chop which pulls this blanking attribute. So attribute scope is B, and we call it B1. And this whole blanking, that's where we multiply the RGB values with. So now I'm actually, that's at the very end, the shape is actually pulling all the colors, and the blanking I have to kind of multiply it at the end. This is something that is also being kind of worked on to happen more in the, and better in the scan shop. It's just like a good to see how it actually affects shapes. Now let's go away from steps. Okay. Oh, saving. Let's just scroll on the desktop. One more example, or
could you show how to use a top?
Yeah. Okay. I'm not a big fan of using a top. I mean, there's two ways, of course. Okay. So a circle top. So the one way is actually to really use a top as an input. Then we would have to change top.
Nice.
Yeah, so now actually we need a bit of blanking. And basically what it does in a resolution of 10 by 10, it scans this image on 100 points. Basically it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 rows. So we need a little bit more. This is 100 by 100 is too many points, but
you can try the auto reduce. Nah, okay. And what's the interview? So this works great though with your webcam. If you use your webcam with it, you can basically do.
okay, with the
sweep, yeah.
With sweep. But of course you can also go ahead and have a trace and filter step size. I'm actually not super sure. It looks okay.
Convert it to yes.
Yeah. So this can be, I don't know. Let's see how good it works with the noise. Definitely it needs a bit more.
Yeah, that's cool. I really like that.
What that means.
Oh, set cones.
Is it difficult to control? Why is it like, yeah, yeah.
Put more.
Does it have a repeat last point or something like that in the software?
And as you can see, here is also just a few words. You can also add a camera to your scan shop. Basically, like now we're looking at it orthographically, but you can also have any kind of camera that also looks at it from an angle, for example. And this is also very helpful if you want to project the same SOP, so the same geometry, maybe from 3 different projectors, laser projectors. You basically just put the camera at the place of where your projector is in real life. And with tweaking, you can kind of match them together. There's one other. Let's go to the super basic, the oscilloscope version.
So could this scan thing sample like shapes that move, or even black and white animation? Could the scan shop sample it like it's sampling the noise here, so you could feed like a black and white animation in it, anything?
I mean, now I just have this circle here, and this could be any black and white animation.
Yeah, and yeah, that was the noise.
Yeah.
Cool. So even a cartoon. Did you try that?
That was what the scan shop was made for.
So now I can also just give this to the, 1,000 should be enough. Chop. So this is really a graph from -1 to.
The samples are the steps for the density.
In
Shop samples.
Here?
No, the length.
The length, yeah, this is the amount of points that it has. So I guess when we change that, yeah, we kind of get a more or less static wave if we have the same amount of points than the sample rate.
So you put like a weird 3D shape, like a sphere.
It definitely, what it looks up is the points are there. It's yeah.
But not look like line parts.
Yeah, even if you draw this way.
It's also, yeah, it's kind of the order of the points is also very relevant. Like even if you want to draw a cube and you have the points, it's kind of like you have to find the best path to do that.
You could try a sphere, two spheres, one sort the points x, so you got one sphere sort this.
Give us label.
Huh? Ah, okay. And then from oh yeah.
Wunschkonzert, Laserwunschkonzert.
Sphere. Or mesh, yeah, probably. Then sort. So we would have 1, 0, and 1, right?
That would be one.
From top to bottom.
You actually have to draw two spheres. The other one is the. So this way, you rotate that. And to get a sphere that has a grid, you would have to have a second sphere. Or a second sword, essentially, another sphere.
And this would be minus 1 and 0?
We have 0, 1, we have 0, 1. Now you need 1, 0.
Oh my god. I'm excited. Yeah, that's what what I mean at the beginning. It's difficult to accept at the beginning that you cannot just do everything. It's a hardcore device that works there, and you have to kind of start thinking in a laser way. Okay, yeah, in the example file, there's a bit more of these processes, and also one example with using a particle soft, which is attached to the mouse, so it kind of goes a little bit more into using more of this touch designer things to actually make shapes. And I also added a camera to the scan job. And there's a visualizer. Okay.
You do it with the circle itself, copy itself. And then you use each copy to scale y, scale x, and then another scale y. Separately.
Okay.
And then make like 5 copies. And yeah, something like that. Yes.
Oops. My head is also turning to get empty.
one, so I guess it would be a copy actually with the stamping to have people work around.
Yeah.
The other way around.
No blanking. Yeah. So it would be on the X. So let's have 6 copies.
But you only have to do a quarter, so 90 divided by 6.
I'm just doing now. Then let's finish. Okay. Is der Effekt des
Can you rotate this field? Yes.
Ja. Ja. Transform. Dann brauchen wir
Just one last question.
Yeah. Yeah. Yeah, it's based with Ethernet.
But this was because that special.
This is this AVB. I forgot to mention it. It's actually not a laser protocol. It's called Audio Video Bridge, and it's basically made for like sending audio and video over a network. So it's kind of the ArtNet of the DMX. So I go out with USB here into this box.
Yeah, this is normal.
Yeah, and then this is the network cable that goes, and it's AVB.
Yeah, but this is kind of new laser because all laser just have
Yeah. This has that's how you can achieve this higher sample rate. But I used to work with the SO3 mic. Yeah, I have one here also.
Yeah, but
But this thing is you can control 25 lasers.
That's the point, because we need
So this thing you can output 128 channels.
And it's just like
you need to have a switch. That's the basic idea with AVB, is that it makes audio and video not this point to point, but like a more networked structure. Exactly. And you work with IPs, you get a feedback that it got received. It's a very nice, but yeah, it's not so. It is like in the super pro area they use AVB, but it's not so much distributed. But this also has the ILDA input, this laser.
Yeah.
They have like no, they are on yeah, what do you think was last bit?
I think mine, yeah, that one was like similar, but like that one, yeah, exactly.
Here?
Yeah.
Yeah, that's a bit of a tricky part. Wow. So als Aufbau ist noch anstrengender als Ausbau. You're welcome. What's your name? But yeah, of course. see your interview on Monday. Today. There are still Christmas meeting of the company. I want to know. Six. Thank you. Nice one. Yeah. I used to work for them. I mean, I worked for them 4 years. Now I'm out since. That was for projects. I mean, I was the first candidate 4 years ago. I was the first one. Now it's like 17. They are super growing. The office is crazy, like super nice office. Yeah, it's like the company drive, it's like drive. But for me, it was too much enterprise. Like it's not so much white noise, the variety of projects got or like it's only the motors. We used to do like other projects more on like stuff with projection or the installation with the flip flops or like different things, but now it's like I'm trying to sell. I mean, it's also super interesting to see how a company develops a product. Like talking to
each company is different. Each company that apply managers and inspires.
Yeah, I mean they make a machine now. I mean I come from art background, like programming was like growing, like I went from yeah, I did programming but was like still in arts. And yeah, so I kind of come from this area, but now at Brightwood it was only like 3, 4 creatives, and that is including me. I'm just the software, and the rest of the people developing motors. This makes like 25 people now, like more like the production. But it's yeah, good to see me coming after the uni as first employee, and nowadays thousands of motors and sell them all like very nice, but very special. By now, it's kind of I really yeah, but I kind of that's also one thing I want to do a bit more like work on producer at some spot. Nowadays, that's right. But I would really focus also. That's why I started I don't know. But actually, if you are interested in that, it's definitely like Stefan and Marcus, they kicked off this workshop. And then Marcus asked me to do some stuff. Since I'm also doing the teacher now, they asked me, like Stefan wants to make something more big like that. It's like maybe in Berlin and Leipzig, like here, and then have something really sweet, like not having like workshops, but we have more other periodic jobs. systems. Then to see how this thing is sponsored by AWS, some other that's something that Shepard tries to find out.
I mean, I do. I work for young girls. Like, for example, I wanted to come with courses, but I couldn't.
Did you use Flash before?
Yes.
Yeah.
Actually, I've been using it in the past 2 years. Last year was started.
I mean, touch it was the same for me in the beginning. It's kind of, you learn very quick the first things, but then it kind of, the growing curve is like this, and then you have to jump once the next step is kind of really get it going. But I mean, I used to learn text graphs, so and there's a learning curve of like, and then you kind of go up. But at the beginning, when you just write code, you don't see anything. Yeah, at the end with the labels, I just rushed through because I mean you can talk about every little digit that you have to change because laser is very specific. You have to be delicate with the numbers.
But it's equal, but you just display zero. So you don't see something that is just display. I just did display too.
Yeah. No, this was luckily
So you phone you just China. The display phone, like a phone, you show.
No, this was done on the
display. It's the same, but
yeah, because I mean the whole deep web is also for me where laser started. So I was able to give also luckily some of the work to Michael who's developing the lasers. And also for him, deep web was new, you know, like he didn't know, okay, let's do it like we did last time, because there wasn't like this before, but he was also doing a lot with integration.
Because I don't know in the school, but it's essential school, like that, sometimes you mess it up quite fast.
Yes, I do.
Yeah,
yeah.
Frame rate and stuff, you start up quite fast.
The whole thing would also like, if you zoom in and out in the network.
Yeah, that's another point.
Has these glitches. Yeah, and I think it gets better the less sample rates. Like because actually the SMB is kind of it has 48,000 sample rate, but I only use it on like 20,000 or 24,000. Then this kind of hiccup.
I use 70,000 even less.
Yeah,
the laser is
so this is kind of, but it's still annoying that it does this like cracking. But it always happens if it not uses a frame.
Okay.
I mean, you can kind of catch it with a script, but it's also not really. Basically, because the scan chop is always one frame long, and if you lose a frame, then this, you know, like it has one frame.
Yeah, exactly.
And now you also see like sometimes it jumps to 2. This is because it dropped a frame, and this one can handle that much better than because then it gets 2 frames of information, and they have a buffer to handle it, and the SLB doesn't.
Okay.
And then it gets 2 frames at the same time, and it's
that makes a lot. I was wondering if I was part of the laser.
No, it's on all of them.
Yeah, this is still the question to use many laser. I don't know if Laser Dream is the way.
I mean, this thing is $800.
Yeah, I see.
It is.
If you want to
yeah, I mean, this is this.
How much you can control how many you can? Like
25. I mean, it's 128 channels. So if you have 5 channels per laser, you can go 25 lasers.
It's fast.
Yeah, I mean, it's 20, yeah, I haven't done so many lasers at once, but.
Okay, cool. Nice to know. This is a new. Okay, then. It was a pleasure.
So it was nice to meet you. Die Raucher gleich alle raus. Stefan ist gleich draußen raus. Der nutzt da sofort die Gelegenheit und da. Wollen wir hier die Aufnahme stoppen?